Naveen Gupta from Coral Telecom. He's a senior 5G service engineer. He has been working at Coral Telecom since last 13 years or more, and he is looking after the installations that the government has initiated and which have been announced as the 5G use case labs. So Mr. Naveen Gupta was instrumental in installing the setup at MNIT Jaipur as well. It was his expertise which made our 5G lab operational. So I welcome him again, and I would request him to uh, uh, present about how these 5G labs are working, and he'll also be giving a demo of how these are getting functional. Okay, so Navinji, you can now share your slides and start presenting.
Right, sir.
Yeah.
Thank you very much. And good afternoon to all of you. I am Naveen Gupta from Coral Telecom. And Ravi sir has told you, I am working from last 13 years in Coral Telecom. And from 3, 4 years, I am working in a 5G department. So this project, I am the project manager. And as per discussed with Satyasai Nanda sir, I will present you in a layman language what we are doing in the 5G lab, what are the protocol structures, what are the equipments we have provided, and also some brief little description of how to check the logs. So right now I'm going to share my screen. Ravi sir, are you able to see the presentation?
We are presently seeing your screen, not the presentation.
Not the presentation. Just a second. Where I have to share, there is a screen one. Okay.
Entire screen. Share the entire screen.
Yes. Right now I think it's okay.
Yes, we are seeing your browser.
Right now
Now,
the
yes,
presentation.
now the presentation is.
Okay.
Full screen. Make it full
Yeah.
screen.
So this is the
You can make it full
5G
screen.
lab architecture. So you can see from left to right.
Please make it full screen.
Okay. Just a minute. It's okay
Yes,
now?
yes, yes, it's fine.
Okay.
Please continue.
So this is the 5G lab architecture, which is deployed in the 100 5G labs by the different vendors. We have 26 5G labs, which we have deployed as a Coral Telecom, and rest of the are done by the other vendors. Architecture is the same. Equipment can be different, but the architecture, protocol stacks, all are the same. So here you can see from, are you able to see my cursor?
Yes, yes,
Okay,
it's visible.
okay, thank you. So you can see here, there are some user equipments. We called it UE as per the 3GPP language. Why UE, not MT? At the time of 2G, we called mobile devices as a MT, mobile terminal, because it's having only the voice facility and SMS facilities, not more than that. After the evolutions in the 3GPP from generation 2 to generation 5, that has become UE. The reason is you can also use the internet. So you can do call, you can use internet, you can use apps, whatever you want to do from the internet, you can do it. So that is become the UE, just a name. Here you can see the equipments. Number one is IoT gateway. Second is drone. There are mobile phones. There is a CPE. There is a 5G camera. And there is a evolution board. So how many devices are there? One, two, three, four, five, six, seven. Seven devices which will be used for the 5G. Means the SIM will be directly connected in these devices. Any doubt in this? Ravi sir? I am audible?
Yes, sir, you are audible, sir.
Okay. Any doubt regarding the SIM, regarding the physical connectivity? Okay, I'm continuing. Then there is a G node B, which is mounted on a tower. It's only the capacity of 100 milliwatt because this is a lab radio and every lab will have to take the license to emit the RF. So that is only of 100 milliwatt as per the DOT. It is non-radiating license, non-radiating experimental license. If you go beyond the 100 milliwatt, you have to take the license from the WPC, and that will cost a higher in millions. Because for the experimental purposes, only 100 milliwatt is sufficient. So DOT is providing the 100 milliwatt license. And there is a temperature soil water sensor. This is the IoT sensor. I am again repeating, this is the IoT sensor, not the gateway. And there is a rack, 30U standard size rack, and there are four equipments. One is Ethernet switch. This is L2. Then there is a firewall. Manufacturer is Cosgrid. And there are two Dell servers. Further classification, I will tell you. Right now, the most important thing in the 5G prospect. There is three basic components in the 5G. One is UE, user equipment, which will be held by the people. Second is radio in general terms. Radio is G node B. And third is core, 5G core, or you can say it NGC, next generation core. So user equipment is a hardware. G node B, it's a hardware. Core is a pure software. So you have seen this. There is a low latency in the 5G network. Why? If you will compare to the 2G network. The reason is in the 2G, there are four components. Mobile terminals, BTS, then BSC, then NSC. So BTS or radio, base station transceiver. BTS or radio in 2G that connects to the BSC. And then all the BSCs will connect to the NSC. But in the 5G or 4G, the radios are directly connected to the core. So there is one leg is removed. So that's why some latency they have covered here. Any doubt in this? Okay. So I am starting from the G node B. In the labs, we have provided the integrated RAM. What is integrated RAM? The integrated RAM is simply there are three components in the RAN architecture. Radio access network. One is CU, one is DU, and one is RU. CU is central unit, central processing unit. DU is distributed unit, and RU is radio unit. So all three components are situated in one single box. So that's why we are calling it as a integrated RAM. Further classification, what is CU, what is DU, and what is RU? CU and DU both are softwares, and RU is a hardware which propagate the RF. What CU will do? CU will control the DU, and DU will control the RU, right? Then I am coming for the core network. As you can see in the picture, there are some basic network functions in the core network. You can see here NSSF, NRF, UDM, AUSF, PCF, NEF, UDR, UPF, SMF, AMF, and there is another component is IMS. IMS is totally independent of core. IMS is only responsible for the voice calls. So do not confuse with the WhatsApp call. WhatsApp call is a different thing, and the voice call which you are dialing via the numbers, that is a different thing. If you want to do the voice call, you will have to do you will have to deploy the IMS, IP multimedia subsystems. The basic components of the IP multimedia subsystems are PCSCF, ICSCF, SCSCF, and HSS. P stands for proxy, I for interrogating, S for serving, and HSS is the database, the user identity which is stored for the voice call for the registration of the mobile phone. Then I am again coming back to the 5G core network. AMF, the first network function, access and mobility function. That is responsible for the registration of the UE. When you will power on the mobile phone, what happens? RAS procedure will going on through the RF network, through the G node B. There is the N1 interface. You can see here. From radio to user equipment, there is a N1 interface. Pure RF, no wired connectivity. Then it will communicate to the G node B, and G node B will send this information through the N2 interface directly to the core. And in the core, that is AMF, the first network function. As you can see here, there are so many network functions: AMF, NSSF, NRF, UDM, AUSF, PCF, NEF, UDR, SMF. And then here you can see UPF, user plane function. It is again, second. UPF is separated. This is only responsible for the user activities when you are using internet. The responsible network function is UPF. So there are separation in 4G and 5G in the core perspective. In 5G, they have split it, the network functions in the two things. One is control plane and one is user plane. So except UPF, all the network functions are in control plane. Any doubt? Okay, sir. Can I continue?
Yes, please continue. I think
Okay.
if the participants have any doubts, they can raise their hands or they can post in the chat.
Okay, no problem.
Okay.
So this is the network architecture for only 5G. Another things, we have deployed the MECs. Multi-access edge computing. The data center nearer to UE. The meaning, how you can understand it. Let's suppose you have a Google server, which is situated in California, and I am accessing this Google server from India. So I have to go first California, and then the request, the result will come from the California. So there is a distance that will take more latency because you have to travel more distance. If a small data center, which is useful for the Indian users, I will put in Delhi. So what will happen? UE doesn't have to go to the California. That will go to the Delhi. So the distance will be lesser, the latency will be lesser. I'm going for the next slide. Just a second. So these are the equipment which we have supplied in the 5G labs. Ravi sir, give me 1 sec, please.
Sure.
Okay. There are two Dell servers. One is 5G core. There is one firewall, one Ethernet switch, one radio, one evolution board, one 5G AI camera, one is augmented reality, one is CPE, customer provided equipment, one is IoT gateway, one is 5G drone, and one is IoT sensor box. So these total bill of material is provided in the labs. Now, these are some IP addresses which can be vary from one lab to another. So this is the specifications of the Dell servers. You can see here, two things are common. Model is same. Two things are common, RAM and CPU. 64 GB of RAM, DDR4, and 48 CPUs. The difference between the two servers is only the hard disk capacity. One having the two hard disks and another having the 6 hard disks. So here you can see here. And right now I'm directly going for the core configuration because core is the heart of the system. Every user equipment will have the identities which will be stored in a core. Radio is just behave like a pipe. So I am giving you a live demonstration. So right now I am accessing the core via the IP addresses. Here my IP address is 14.35. We will go to the settings and search for the phone. So here you can see the how many mobile phones or SIMs has been has the databases. Here you can see this is the INSI, International Mobile Subscriber Identity. One is the K value and one is the operator key. So these keys should be matched when you will attach to the network or register to the network. These key will be verified via the core. If these keys are verified, then the registration process will complete. If these keys are not verified, you will be thrown out to the network. Let's suppose you are using the Geo SIM. When you will try to attach the Geo SIM to the network, that will go to the Geo network only. That will attach via the Geo network, not via the Airtel. Why? Because of these keys. These are the basic components. We call it K values and operator keys. That things are stored in the SIM as well as in the core network. And MC, this is a 15 digit, and you are seeing here the first 5 digit 00101. What is that? That is PLMN. I am showing you what is PLMN. Public landline mobile network. This consists of two things. One is MCC and one is MNC. What is MCC? Mobile country code. And one is MNC, mobile network code. That is fixed by the 3GPP. In the left, as you are seeing, I am using MCC as a 001 and MNC as a 0. What is the PLMN for the public network? Public network means Airtel, Jio, BSNL, Vodafone. For this, as per 3GPP, what is defined in India? That is 405 and 404. You will check from your mobile phone also. Your INSI will be start from 405 or 404. India is divided into two regions, north and south. In Mumbai, the MCC will, if you will take the SIM from the Mumbai, the MCC will be 404. And that is fixed. You cannot change. For the lab purposes, we are using 00101. That is a test PLMN. So all the testing purposes, this is the predefined PLMN via the 3GP. So we are also using this PLM. So this is most important. Again, going back to the presentation. The equipments which are provided in the lab. So that is 5G AI enabled camera. So these are some basic parameters which we have supplied in a 5G network lab. The camera is from the manufacturer Sparsh. That is again an Indian company. What it can do, it has basically two types of connectivities. One is from Ethernet and one is from 5G network. What is the meaning of the 5G network? Inside the camera, there is a modem in which you will insert the SIM. So this camera doesn't need any wired connectivity to stream the video. That will directly connect it to the radio and then the core network. Another thing, how to access it. That will I'll show you in lab also, in the live demonstration. This is the customer premises equipment. You all heard about the Geo Air Fiber. What is Geo Air Fiber? In Geo Air Fiber, what Geo is doing, they are providing this kind of equipment, and it having the SIM connectivities that will connect it to your 5G network or 4G network, and that will provide you the hotspots where it can use in the rural areas. There is no fiber connectivity where you can use this customer premises equipment. If fiber connectivity is not there, there will be the RF connectivities for the 5G or 4G. So you can use this kind of equipment for taking the advantage of internet. So these are the some parameters. Another thing is IoT gateway. The manufacturer is Cosworth, again a Chennai-based company. What IoT gateway can do? You can connect multiple IoT devices with this gateway with several kind of connectivities. This IoT gateway will also having the SIMs. There are provision of three SIMs in this particular IoT gateway. Through the IoT gateway, this IoT gateway will connect to the core network via the radio. And IoT device where you can connect, there are two types. One is Wi-Fi and one is Ethernet. So the IoT sensor device which we have provided in the lab, you can connect the IoT sensor devices to this IoT gateway via the Ethernet or via the Wi-Fi. So IoT devices data will send to this IoT gateway, and IoT gateway will send the data via the RF network to the particular node. So these are the configurations for the IoT gateway. This is the Coral. This is made by the Coral. This is the IoT sensor. So you can see here, there are 5 types of sensors we have provided. One is light, one is soil, one is TDS, and one is temperature, and humidity. Sensors also be provided in the labs. Here you can see the connectivity. How we are connecting these IoT sensors to the IoT gateway. You can see here there is a Ethernet which is connected to the sensor devices. So the sensor devices which generate the data that will go via this Ethernet to the IoT gateway, and IoT gateway will transfer this data to the network through the RF. So these are the data which we are showing on an NMS, just like temperature, humidity. Another device is drone. It is also 5G enabled. There is also a SIM inserted in this drone that having a both type of connectivity, 5G as well as Wi-Fi. Most of the uh, drones are connected. They make their data link via the Wi-Fi. But there is a problem in a Wi-Fi. Up to Wi-Fi 5, there is no handover. Let's suppose there is a case with the Delhi police. They want to fly the drone from North Delhi to South Delhi. But through the Wi-Fi, they cannot maintain the data connectivity. So how they can achieve it? They can achieve via the 5G network. If this drone will use the 5G network, in 5G network, there is a possibility of handovers without interruption. This kind of activities or this kind of output you can only achieve through this 5G network, not via the Wi-Fi. This is the augmented reality. AR VR devices, 3D views for some academic purposes. You can use it. Some professor lectures you can use for the learning purposes also. And this is the radio, 5G radio. This is what band we are using. It is N78. What channel width we are using? 100 megahertz. FR1 frequency. In FR1 frequency means from 0 to 6 gigahertz. And up from 6 gigahertz to upper, that is FR2. So in the lab, we are using FR1 frequency. The frequency band is N78, which is in particular frequency, you can say we are using 3.65 gigahertz central frequency. Power emission is only 100 milliwatt. And that is what is MIMO technology we are using in the lab? That is 2T, 2R, 2 transmit and 2 receive. And because we are using N78 band, this is the TDD band, time division duplexing, not FDD. In FDD, you will have to use 2 frequencies. But in TDD, you can use only 1 frequency for transmit and receive. Another equipment is evolution board. This is also made by the Coral. And what is the purpose to give this box via the DOT to the labs? Actually, for the development prospect, we can have the debug logs from the core. We can have the debug logs from the radio, but we cannot have the debug logs from the user equipment. Samsung will not provide you the modem locks, or Google or some other mobile manufacturer, they will not provide you the the modem locks. What we are doing in this box, there is a 5G modem, there is a Wi-Fi modem, there is a MIMO technologies up to 8 cross 8. SIM connectivity is also there. Dual SIM connect. You can connect dual SIM in this Anubhav box. What you can do? First of all, you can see the modem blocks through the AT commands. What is actually going on the modem? In the mobile phone, there are two things. One is CPU and one is modem. CPU is responsible for your operating system, just like Android or Mac OS, iOS. But for the 5G connectivity or RF connectivity, the hardware which responsible is modem. You have heard about the Snapdragon or MediaTek, etc., etc. These are the modems which communicate with the 5G network or RF network. So you can directly see the logs of that particular modem. So that is the advantage. Also, this box having several types of connectivities, just like GPIO ports it's have, SP2IO ports it's have. So you can also integrate your solutions with this evolution board and test your things with the 5G network. So this is very useful equipment which is provided in the labs. This is the firewall for internet connectivity, or firstly, it is provided for the internet connectivity and make the rules. If the MNIT Jaipur wants to transfer the data to IIT Kanpur, so that will not be without encryption or without tunnel. So you can make IPsec tunnels, VPN tunnels via this firewall. So this is the basic use of IP networking. This is the network switch, 24 port PoE L2 switch. All ports are PoE up to 1000 Mbps. VLAN support is also there, and also the fiber connectivity. There is SFP port also. 4-port SFP also available in this dealing switch. Other things are not relevant. So what I'm going to do, Ravi sir, can I give a demonstration?
Yes, Navinji, please.
Okay. Okay. So I will give you the demonstration also, plus Wireshark log as well, so you can understand better. So here in the lab, I am in JP Institute of Technologies, and I am accessing the code. Core IP is 192.168.14.35. So here I want to show you how we have deployed the core as per the TCIL and DOT instructions. So I have show you the network functions. All the network functions are in the container. So every network function having the different identities. So you can see here, there are the containers, and these are the IDs of the containers. When it was created, what is the uptime of the containers, and what container name? Just like this is UDR, User Datagram Repository, UDM, User Datagram Management, SMF, Session Management Function. Every UE will have the IPs when it will connect to the network. I will show you in the demonstration. These are the components which is for the 4G. So you can also connect your 4G radio also. This is the network slicing, network repository function, AUSF. So these are all the network functions. Every network function is in the different container. Another things. Here you have seen the status of the container only. That doesn't mean this service is working. This means this container is working, and you want to see if this service is working or not, you will have to go in particular container. So how can you go? I am going first of all, the first container is AMF. So you can see here the ID of the AMF container. And here you can see the service. Again, the simple Linux commands. So here you can see this service is activated. What service? AMF. From how long? 12 hours, 52 minutes. So this we have what in what container? That is AMF. Then exit from this container. We will go on the shell. Then another container, just like most important SNS. So right now you are in the SNS. You can see here the ID of the container. And you can see the service status. So here you can see it is up by 2 hours, 50 minutes ago. As per this architecture, you can see how the container is working and what the services are working. If you are getting difficulty or you want to debug, you will have to do these activities. So right now what I'm going to do, the Warshak law. What, what will happen in the network? First of all, the core network should connect with the G node B. That means radio. So how it will show you, I will show you on a Warshak. Okay. I'm taking the logs from the source. Just taking from the, these are the interfaces. So take every interface. And the IP address of the Gnode B is, so I'm just going to reboot the Gnode B. Give me 1 second. Fourteen dot 15, just I have rebooted, so that will take 2 minutes to bring it up. So that has bring it up on the network. So here you can see, first of all, to access the Gnode view. You can see here, these are the services in Gnode view process. That will take 3-4 minutes to bring it up. There is a link when it will connect with the access and mobility function. You can see here also on the Warshak logs. So I'm just stopping and explaining you what is going on there. Here you can see here, there is a source and there is a destination. Here you can see the source is 192.168.14.15. That is the Gnode B. And the in destination, the IP is 192.168.14.10. This is the IP address of the AMO. There is a init process. Init, then acknowledgement via the core, then cookie, and the cookie acknowledgement. So this is the SCTP, Stream Control Transmission Protocol. So transport layer is up till this packet from G node B to core. Then after up the transport layer, what the packet will be sent via the G node B. This is NGAP. You can see here the protocol. Next generation application protocol. What is NG setup request? And what will the response? Response will be coming from the core. Core is 14.10. NG setup response. So I am just opening this particular packet. Successful outcome. So that means the G node B is connected with the core network with how many of parameters? Here you can see mobile country code 001, mobile network code 01, and these are the network slicings. This is very important. You can see here that value, just for remember, SST value 1, SST value 2, SST value 3, and there is a size differentiator, SD. I will explain you what is SST, what is 1, what is 2, and what is 3. What is the difference between 4G and 5G? The main difference is network slicing. So these are the three basic slices. One is EMBB, one is MMTC, and one is ultra low latency. Enhanced mobile broadband, massive machine type communication, ultra reliable low latency communication. So different types of use cases will be handled differently in the 5G network. This cannot happen in a 4G network. Let's suppose I am the user and I want a higher throughput. I want to stream the 4K videos. I will need this slice, like a broadband. So that's why it is called EMBB slice. Massive machine type communication, machine to machine communication, V2X communication, vehicle to vehicle, vehicle to anything. IoT devices, several IoT devices. Let's suppose in my house I can use 100 IoT devices. Then I will need a lesser throughput, but that IoT devices should communicate with each other. Ultra low latency communication that is used in practical world, for example, in Kavach program in railway. The sensor data should go in a very fast manner. IoT data will be in bits or bytes, maximum in bytes, and that should be reached to the node immediately. Otherwise, what will happen? The two trains are coming from each other in the opposite direction, and the speed is 100 kilometers. So relative speed will be 200 kilometers, and you will have to apply the brakes. How the system will know when to apply the brakes? The data should come in a ultra low latency manner. So it doesn't need the high throughput. It's need only the latency. And I have shown you what is SST. SST1 is EMBB. SST2, ultra low latency, and SST3. It is massive machine type. So what we have shown, the core supported all the network slicing functions, all the vectors. Also, you can see from the radio. Here you can see the SSTs. What slice the radio supports? Radio right now I have configured for the two slices. One is AMBB and second is ultra low latency. So at a time, the network will behave for the AMBB slice and for the ultra low latency slice. So I think that is clear. Here you can again one more important thing from the core prospect, the SIM configuration. These are the SIMs MC. And when you will edit it, you can see here. This is the subscriber identities. These are the operator keys. What throughput you have given to the particular SIM. So for by default in the lab, what we are doing, we are giving 75 Mbps for uplink, downlink, sorry, and uplink for 20 Mbps. You can also increase or decrease it. And this SIM is configured for the EMBB slice. And there are multiple APNs. One is internet for your data. Right now, I am using only data, not the voice call. Here you can also increase or decrease your SIM speeds through the core network. It doesn't mean I am giving 1 Gbps, so this you will get the 1 Gbps. That also dependent on the radio network. If radio is not capable to give the throughput, that will not work. Another thing, here you can see MBR, maximum bit rate, downlink and uplink. This SIM will get only maximum of 75 Mbps of downlink and 20 Mbps of uplink. There is a guaranteed bit rate also. That is intentionally I have leave it blank. When this SIM will be configured for the ultra low latency, then I will configure it for the guaranteed bit rate. If this SIM will have the guarantee to transfer the data in that particular bit rate configuration. So I am just attaching a mobile phone. Just a second. So this is the mobile phone. And I am also starting the lock. Just off the flight mode. You can see this UE is connected. Apply the filter for the protocol. So here you can see the network 5G. This video session is up. So this mobile or UE is attached with the network, the 5G network. So these are the protocol stacks. What happened when UE sends the attach request to the core network? From where 14.15 is a radio and 14.10 is a AML. There is first message. Initial UE message registration request. RRC establishment. So this is the first message. Then if you will read the protocol stack, you can understand what is happening. Context setup there, UE radio capabilities, and here registration complete. After registration complete, it doesn't mean you will get the services. This is only the registration complete. That means OP values and K values are matched of this SIM with the core network. Then after that, there is a PDU session establishment. What is PDU session? I told you you will get the IP. This is the PDU session. This is the 5G data. Where you can see what IP it gets. Go to the setting, then about phone, then status information. So there is a IP address. 10.45.0.22. Through this IP address, you will get the internet. So here you can see one more thing I want to show you. What is the MC of this particular phone? 001015066. My cursor, you can see. So this is a private network SIM and it is connected with the lab network. Also, you can use the internet. So how you can check what is going on? So please again see. What was the IP address of the device? 10.45.0.22. Filter it. Refresh. You can see here the YouTube is working. How the packets are flowing. Just I am stopping. These are the GTP tunnels. Look at the protocol. Gateway tunneling protocol. So every data will go through the GTP protocol. This is the IP address of the device and this is the gateway from where it is going. Here you can see the IP address of Google, YouTube. So that's how the devices are connected with the internet. You can analyze all the packets, where it is going. And one more device I have in the lab, which is camera. So please wait for 1 minute. Let me power on the camera. You can easily find the IP address, which IP is provided by the code to the particular SIM. So just opening the camera via the SIM. No need of that. I have to change the IP. Oh, so here you can see the IP address, which is provided to the SIM via the core network. Just enter the username password. And here you can see I'm in lab. So right now I have access of only mobile phones and this particular camera. Other devices I do not have, so I cannot demonstrate. But the function of the every device will be the same for the 5G network. There is a SIM which will be registered with the 5G network, whether it is in mobile phone, whether it is in IoT gateway, whether it is in uh, camera, whether it is in drone. Ravi sir, anything from my side?
Anything?
I think I have demonstrated each and everything.
Yeah. So
Participants.
participants, we have Mr. Naveen here waiting for any queries that you may have.
Write in the chat box.
If you have the query after this session, please email me. I will reply it back.
Yeah, Mr. Naveen is available at naveen.kumar. I'll just put his. This is his email ID. Yeah, there's one question. Is there any possibility or option to modify core coding or any protocols?
Core coding, right now I cannot provide you because this is the commercial product and we cannot provide you the source code. But yes, configuration part we can provide you. The XML files, YAML files we can provide.
So, but that would be means just for understanding how the interfacing works.
Protocols are, I have shown you in the workshop how the protocols are working. Protocols are working, protocol means set of rules defined by the 3GPP. So these will be the common. If let's suppose you are using the lab core and you are taking some other vendors Gnode B. So that should be work with this core. So these are the protocol stacks. That will be the similar. If there is some difficulty, just contact us. We will debug all the things.
Are there any open source tools which can work like a 5G core?
There are lot of, just like Open5GS for the core, or you will go just simply go to the Google and ask open source 5G core. There is one is Open5GS, one is Free 5GS. There are a lot of communities are working on a core, and all are open source. You can also take the code from there. And for your knowledge, I am also telling you, we are also using Open5GS, some libraries. Some libraries we are taking from the Open5GS, and some libraries we are written by our own. Our team is also associated with the Open5GS. Just say like NEF, this network function is written by the Coral. NWDF, that network function is written by the Coral. AMF is written by the Coral. We are using AUSF from the Open5GS, open source library. You can also integrate it. Just like there are so many RAN, just like SAS RAN, this Geo is working on this, just a second, OpenAir, OpenAI, OpenAir interface. So Geo is doing R&D from last 4 years. They want to make their own equipments in RF network. So they are using OpenAir. So there are a lot of open source are available, but you will have to do work. And there are a lot of bugs also. That's why they are open source. So you will have to work with the communities. Then the community will also definitely help you. There are communities which will provide you support in the paid manner also. So you can start the development work if you want to do in this manner.
Yes, nice to know. So, if there are no other queries, I think we can end this session from Mr. Navin Kumar Gupta now, and we will move on to the next session. So, thank you.
Okay, Ravi sir, I am leaving. If
Yeah.
there is no query, then please, if you are having any query after the session, please email me.
Yeah.
I will revert it back.
Yes.
So thank you very much, Ravi sir.
Thank you, Navinji.
Bye.
Bye. The participants will be starting shortly in about 5 minutes for the next session. I'll be delivering the next session.